Hello, everyone. So, we are going to um, do some rational equations now. We've been doing rational expressions where we're working with kind of one side of the equation and not necessarily solving for something, but we do eventually want to shift towards using an equation. And the strategies that we've been using for multiplying, dividing, adding, subtracting rational expressions is exactly what we're going to use here. But since we've got an equation in there, um, we want to move towards solving for the x, and there's a couple of things that we can do to solve for it, to try and slowly condense our equation down till we have a final x value, or use the quadratic equation to find two possible x values. So if there's just a single fraction on both sides and you have a variable in the denominator, you can cross multiply to bring up the values. So just simple example, 1 over 2 equals 3 over x. If you had something like this, you're going to cross multiply. That just means multiplying both sides by x to get the variable out of the denominator. What that effectively does is brings it up to the other side. So if I multiply both sides by x here, then that would cancel out that x off the right side, but better than that, it brings it out of the denominator, and our new equation would be x over 2 equals 3. So if we have multiple variables on both sides, then we need to we're going to cross multiply both of them up to either side, and obviously it's going to get a little bit more complicated, complicated when we have something like x minus 1 in the bottom, or even a quadratic. When it gets a little bit more complicated, one of the first things you want to do is try and combine fractions. Like if you're adding two fractions on one side, just forget about the other side for a minute and try and condense that one into a single fraction. Then you can proceed with cross multiplying. Or if you you can always go to the go-to, and that's find factor all of the bottom terms that you have, and then find the greatest common factor, the lowest common denominator, sorry, and multiply the whole thing by the lowest common denominator, and that will guarantee chop out all of your denominators, and then you can proceed with adding and multiplying. So let's try some of these. So first thing we want to do, non-permissible values. Can't forget about that. We're dividing by x here, so our non-permissible value, x can't be 0 in this case. We're just setting this equal to 0, so x can't be equal to 0. So there's a few things we can do here. In this case, where there's not too much that, like, there's a couple different strategies we can use. The way that I would approach this one is to multiply by that lowest common denominator, which in this case, the only denominator in all four of these pieces is x. So if you multiplied everything by x, you would effectively get rid of the x. So if I did 4 times x and then plus times an x there, equals 7 times x plus 3x over x. So multiplying everything by x, look what's going to happen. We can cross off the x's out of those two, and now we have 4x plus 2 equals 7x plus 3. And now we're down to much simpler algebra. We want to manipulate this around. The smart approach would be to kind of look at this and be like, how am I going to end up with a positive x? So if you subtract 4x from both sides, you'll end up bringing the 4x over here and to the right side, and you'll have a positive value, so you're going to bring your 3 to the other side. So let's do that. Let's subtract 4x from both sides, and we'd be left with 2, and then 3x plus 3, and then if we were to subtract 3 from both sides, we would have negative 1 over here equals 3x, and then we can finish solving by dividing by 3, and we get our final answer of negative 1/3 is our x. So that was a simple example. Let's bump it up a bit here. So we can either multiply everything by x plus 1 times x plus 2. So that would be the the lowest common denominator between these two. Or we can cross multiply, which is honestly effectively the exact same thing. So let's cross multiply for this one. We're going to multiply the whole thing by x plus 2. So I'm going to write out the whole thing, non-permissible values first. Non-permissible values, x plus 1 equals 0, and x equals negative 1, and then x plus 2 equals 0, and x equals negative 2. So as I was saying, I'm going to multiply everything by x plus 1, just to show you how the cross multiplying works. So multiply x plus 1 by this 5, and we still got the x plus 1 in the denominator for now, and then we'll have 2 times x plus 1 divided by x plus 2. But this x plus 1 is going to cancel out. So here's my new equation. 5 equals 2 times x plus 1 over x plus 2. Notice how I've just effectively taken this piece and moved it up to the other corner. That strategy only works if you have two fractions, one on either side, the simple cross multiply thing. But let's do that. Let's just bring up this x plus 2 to the other side. It is a worthwhile trick because you use it so often. It's really common to be able to use that in physics and other things. So let's bring up this x plus 2 to this side. And then we'll have 5 times x plus 2 equals 2 times x plus 1. Distribute inwards, so we'll have 5x plus 10 and 2x plus 2. And then solve. I want to bring the 2x over here, so I have a positive remaining x. So subtract 2x from both sides, and I'll have 3x plus 10 equals 2. Bring the 10 over here, so subtract 10 from both sides, and we'll have 3x equals negative 8. And then divide both sides by 3. And we have x equals negative 8 over 3. And there's our value. Another example. So we have 3 values here. Let's factor this one to see what it turns out to be. I suppose non-permissible values first. We'll do so in PV x minus 4 is equal to 0, so x equals 4, and then x plus 4 is equal to 0, so x can't be negative 4, and then x squared minus 16 equals 0, so x squared equals 16, square root both sides, so x equals plus minus square root 16, so x can't also equal plus minus 4. Oops. So just something to note here. Notice how our x values turn out to be x plus 4 and x minus 4. So these are going to be cancelable when we finish solving this. You'll notice that it's going to share these two. So let's split this one. X squared, that's a square number, minus a square number, that's a difference of squares. So let's split that. It's going to be the square root of this plus minus the square root of this. So x plus 4 and x minus 4 is going to be our values. So 1 over x minus 4, let's write that out, plus 2 minus x plus 4 equals 5 over, we can write that here if you want, x squared minus 16. It's a difference of squares, turns into x plus 4, x minus 4. And so x plus 4, x minus 4. So getting a common denominator wouldn't actually be all that difficult. I can multiply this fraction by x plus 4, and I can multiply this fraction by x minus 4, and then we would have a common denominator across the board. But let's multiply everything by that common denominator. So all three of these factors share x plus 4 and x minus 4. So if we were to multiply everything by that common denominator of x plus 4 and x minus 4, we would eliminate this from every single one of them. So we are going to do that. So x plus 4, x minus 4 times 1 over x minus 4, and then plus x minus 4. So notice how this strategy of just multiplying everything by the lowest common denominator is longer, a little bit more writing, but it gets the trick done. So, and then 5 times x plus 4 times x minus 4. So remember, you can do anything you want with an equation, as long as an equation states, everything is kept equal. So multiplying everything by x plus 4 times x minus 4 is a perfectly legit strategy. You're keeping it equal. Everything's still balanced. But we come to this desirable result of being able to cancel out all of our denominators. So we're left with x plus 4, and we're just going to distribute that 1 inwards because it's just a 1. So x plus 4 plus, then let's distribute the 2 as well, plus 2x minus 8, and then equals just 5. Combine together like terms, so 3x minus 4 equals 5. Bring the 4 over to the other side by adding 4 to both sides. 3x equals 9. Divide both sides by 3 to find that x equals 3. All right, one for you guys to try. Exact same strategy as the last one. Don't forget that you're subtracting in here, so keep note of that. So you guys can pause it and give it a go. All right, so let's do our non-permissible values. So x plus 2 equals 0. So x equals negative 2. Or x can't be negative 2, sorry. X minus 2 equals 0. So x can't equal 2. And then let's factor this one first, just so we can see what that turns out to be. It's another difference of squares. Perfect square minus perfect square. So it's going to turn into the square root plus minus a square root of this plus minus the square root of this. So square root of x is x. Square root of 4 is 2. So x plus 2 times x minus 2. That was x squared minus 4 equals. So in the bottom here is going to be an x plus 2 and an x minus 2. We already did the non-permissible values for those, so we can skip that. If it is different, if they're different pieces, you're going to have to solve for them. But if they're the same ones, you don't need to keep repeating it. Okay, so in this case, all three of my values here have an x plus 2 or an x minus 2, and this one has both. So my lowest common denominator, again, will be x plus 2 and x minus 2. So we could multiply everything by x plus 2, x minus 2 like the last one, but let me go with a different strategy. I'm going to use fraction equivalency. I'm going to change this one into, I'm going to find the lowest common denominator between these two, and if I find the lowest common denominator between these two, I'll be able to combine them. So let's do that. Let's just work with that left side for now. So 3 over x plus 2 times 5 over x minus 2. I want these to have a common denominator, so I'm going to multiply this fraction by x minus 2. So 3 times x minus 2 over x plus 2, x minus 2. And then that not equals, minus. And I want this to have a common denominator. It's missing a factor of x plus 2. So let's multiply this whole fraction by x plus 2. And again, the goal that we're leaning towards here, using fraction equivalency to combine these two on the left. So we're multiplying by x plus 2, so that goes in there too. And now that I have a common denominator, you can subtract straight across. So this will be 3 times x minus 2 minus 5 times x plus 2. And that's all over x plus 2, x minus 2. Let's solve out what we can here. Let's do the 3x. 3 times x minus 2 would be 3x minus 6. And then this negative 5 times x and 2 would be negative 5x minus 10. And then that's still all over x plus 2, x minus 2. Now, let's bring back our equation. So 2, and then we factor that. So x plus 2, x minus 2. So here's a cool thing about having a common denominator on both sides. Let's go with a really simple example to, just off the side here to demonstrate that. If I had something like 2 over, let's go, no, that'll do. 2 over x equals y over x. Then think about what the result of this is. If I have the same denominator on both sides, imagine cross multiplying. Imagine multiplying both sides by x. What's going to happen? I'm going to cancel it out from both sides. So in other words, if you have the same denominator on both sides of the equation, that's why this strategy can be quite handy. If you have the same denominator on both sides, they're going to cancel each other out. When you try and cross multiply this up to the other side, you would end up having an x plus 2 and an x minus 2 up here with this. So let's do that. Let's multiply, let's cross multiply this by bringing this up to the other side, or you can bring this one up to the other side. It's not going to matter. So that'll turn into x plus 2 times x minus 2. And then we're multiplying that by 3x minus 6 minus 5x minus 10. I suppose we could have combined together some things there. And then on the right hand side, we're just left with 2. Don't forget that we still have our denominator because we just crossed that up. X plus 2, x minus 2. So now these are going to cancel. This step is kind of unnecessary. Right here, if you have the same denominator on both sides, one fraction equals another fraction, same denominator because you've made them into the same denominator by using lowest common denominator, then they're cancelable right here. These would all be gone. And you'd be just left with that 3x minus 6 minus 5. No, we're going to combine them now. No point rewriting that again. So 3x minus 5x is negative 2x, and negative 6 minus 10 is negative 16, and now that equals 2. Let's bring the 16 over to the other side. We want to isolate our x, so negative 2x, that would be plus 16, so 18, and then divide both sides by negative 2, and our x equals negative 9. All right, another one to go here. So in order to do our non-permissible values, we're going to have to factor this one first. So we're looking for, there's no a term, so we're just looking for two factors that multiply together to give you 6, but add together to give you negative 1. So looking for factors of negative 6, 1 and 6, and 2 and 3. The only way to sum these together to get a negative 1 is if you had a negative 3 and a positive 2. So we're going to turn that fraction. With no a term, you don't need to worry about decomposing the middle. You can just fire this right into x plus 2 times x minus 3. So this is going to, let's rewrite it. So 3x over x plus 2 minus 5 times x, 5's over x minus 3 equals negative 25 over x plus 2 x minus 3. So at this point we can do our non-permissible values. Everything in the bottom is factored. So let's do that. We have x plus 2 on both sides. We have x minus 3 on both sides. So let's just do the x plus 2 once and the x minus 2, x minus 3, sorry, once. So what would make x plus 2 equal to 0 is negative 2. And what would make x minus 3 equal to 0? And that's positive 3. All right. So there's all of our side work. Let's go with the other strategy this time. Let's multiply everything by the lowest common denominator. All three of these share factors of x plus 2 and or x plus 3. So if we multiply everything by x plus 2 times x plus minus 3, we'll cancel out all of our denominators. So x plus 2 times x minus 3 over x plus 2, times 3x still. So x plus, x plus 2 times x minus 3. And then minus, so x plus 2, so, and then x minus 3 times 5 over, actually, sorry, this left one. Getting ahead of myself. Just realized that the x minus 3 isn't in the bottom there. I'm not using fraction equivalency this time. So we're multiplying everything by the lowest common denominator. What was I saying? Okay, so in the bottom here we just have x minus 3. And then that equals 25, negative 25 over, times, we're doing the lowest common denominator into everything. Okay, now we're going to cancel out whatever factors we can. The x plus 2 out of that fraction, the x minus 3 out of that fraction, the x plus 2 and the x minus 3 out of that fraction. We're going to have to distribute this 3x into here, so 3x times x is 3x squared. and 3x times negative 3 is minus 9x. And then minus, distribute the 5 into here, so that'll turn into negative 5x and minus 10. Remember that negative is going to apply to both of them. Flip both their signs, and then equals negative 25. Okay, let's combine together our like terms. You can probably see that we're gonna have a quadratic here. So let's actually bring this negative 25 over to this side so that we complete our quadratic. And then remember, if a quadratic is equal to 0, you can use the quadratic equation if necessary. So negative 9 x minus 5x would be negative 14x. And then we want to add 25 to both sides to bring this 25 over, which will leave us with plus 15. And then that's equal to 0. So we should check if these will factor nicely to see if 3 times 15 is 45. Just going to pop that over here to see if 45, any of those can sum together to give you negative 14. Since this is a plus, it's going to have to be two negative values. So let's see. 1 times 45, 2, or sorry, not 2, 3. 3 times 15, 5 times 9, and that's all of them. So we can get it with negative 5 and the negative 9. So we don't need to use the quadratic this time. So we're just going to decompose this middle term into the negative 5x and the negative 9x. Oh, that's handy. That was there. It was already set up for us, but it doesn't hurt to go through the motions. So plus 15 equals 0. So group the first and the second term and add them. Just going to slide that negative over. Factor out the x, and you'll have 3x minus 5. And out of here, we can factor out a 3. Let's factor out a negative 3 to get rid of the negative in front of our x. So minus 3 times, and if we take negative 3 out of that, we're left with 3x minus 5 equals 0. These two terms share a common factor of 3x minus 5, so we'll factor out 3x minus 5, and what we're left with is x minus 3. So two values for x here. Set the 3x minus 5 equal to 0 to solve for it. And so 3x equals 5, and divide both sides by 3 to get x equals 5/3. And the other one is x minus 3. Solve for that. So x equals 5/3 and 3. These are two values for x. And that's all for this one. Thanks for joining me.